Data structure provides efficient way of combining these data types and processes data. So when it comes to the linear, again we have three important data structure, that is stack, queue as well as linked list. So when it comes to the non-linear data structure, there we have trees as well as graphs. What do you mean by primitive data structure? It is a type of data structure where the data will going to be directly operated upon the machine level instruction. Hello everybody, a warm welcome to one and all. Welcome to the session 1 of unit 1 of a subject called data structures using C, which is of B.Ca second semester subject. I am Rohini TS, Department of Computer Science, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. So in the first session of this unit, we will be learning regarding this introduction to data structure. Already we know the syllabus of this unit 1, isn't it? So now we'll see the first thing which is related to introduction to data structure. So as we all know that data and information will going to play a very important role in all the aspects. So then what do you mean by data here? Data is nothing but it is a raw fact that needs to be processed. And can I consider everything as a data? Yes. So data can be anything. It can be either in the format of text, it can be in the format of numerics, alphabets, characteristics like alphanumeric or any of the digits. So data can be anything, and organizing that data in a well structured manner, for that reason we are going to have this data structure. So we are learning this data structure by making use of this C programming language. So representation of that data in the memory organization is also very important. So as we all know that computer understands only zeros and ones. Whatever the data that we are giving will be converted into machine understandable language. So that we require proper arrangement of that data in the memory will going to be very important. Then we'll see the definition of this data structure now. What do you mean by data structure then? So data structure is the way of collecting and organizing the data in such a way that we can perform operation on these data in an effective way. So what do you mean by data structure here? It is a method or it is a process of collecting and organizing the data. So if I am collecting and if I am organizing all the data in a well structured manner, then that will going to help us in order to perform an operation as well as in the effective manner. That is what data structure is all about. So representation of that data in the memory is important, so that organizing that data and collecting those data which is necessary for my operation will going to help me out in order to get the resultant in a efficient manner. That is the definition of this data structure. So now we'll see regarding this data representation, why it is necessary to have a data structure. So as I told, computer will going to understand only zeros and ones. So whatever the data I have, that needs to be represented, that needs to be stored in a computer memory, isn't it? Then only it can fetch the data, then that data can be used for processing. So here computer memory is used to store the data which is required for processing. So this process is called as data representation. Then I have to specify the type of data. So if I get to know the type of data, then it will be easy for me in order to give the type of data. For example, if I wanted to specify age, whether it needs to be what only numbers or it can be what alphanumeric or it can be only text format, then I have to specify what kind of data I am supposed to give as a data here. So that is what you have to specify the data type. So data may be of same type or different type. So as I told, it can be homogeneous data or heterogeneous data. If it is homogeneous, same kind. Heterogeneous, multiple kinds or a different kinds. So that data structure provides efficient way of combining these data types and processes data. So when I am dealing with a data and information, I can't expect all the data to be in a homogeneous manner or all the data needs to be same kind. So we can't expect that. I have to deal with data which is of same as well as different data. So that this data structure will going to help us in order to organize and in order to store all those same or different kinds of data in order to perform the operations in an efficient manner. That is why we require this data structure. So now we'll see how this data structures has been classified, that is types of data structure. So if you see this one diagram, you can easily understand that data structures has been classified into two parts. One is primitive data structure and another one is non-primitive data structure. Under the primitive data structure, we have some more example. So that includes integer, character, float as well as pointers. So reference, all these comes under primitive data structure. Then what about the classification with respect to this non-primitive data structure? You can see here it is of three types. One is arrays, files as well as list. So when it comes to the first type of a non-primitive data structure, there we have arrays. So in the arrays, again we have three types. One is single dimensional array, two dimensional array, and also we have multi-dimensional array. So this is related to array, and in your syllabus you will be not working regarding this files. So no need to worry about the file types here. And also we have a list. Again, this list has been classified into two types. One is linear list and another one is non-linear list. So when it comes to the linear, again we have three important data structure, that is stack, queue as well as linked list. So when it comes to the non-linear data structure, there we have trees as well as graphs. Okay, so totally we have two kinds in the data structure, primitive and non-primitive. In the primitive, we have integer, float, character, and as well as we have pointer. When it comes to the non-primitive, it has three types: arrays, files, as well as we have list. So in the arrays, again three types: one dimensional, two dimensional and multi-dimensional. In the files, we have text file and a binary file that we won't bother in your syllabus. Then when it comes to the list, again of two types, linear and non-linear. In the linear, we have stack, queue as well as linked list. And in the non-linear, we have trees and graphs. So all these data structure will be studied as a particular chapter in your syllabus. So as of now, you just understand what is the classification or a types of data structure. So now we'll see about this primitive data structure. So as I told, in the primitive data structure, we have integer, character, float, pointers. Already all familiar with all those keywords, right? So what is that? That represents the data type. For example, if I wanted to take any of the data of a whole numbers, which should not include any fractional part, then I have to go with integer data type. If I wanted to take only character, then I have to go with a char data type or a character data type. If I wanted to take a stream of character, then string. But we don't have string, so I have to take a char of array. So that is what you have to remember with respect to all the data types. Then how this primitive data structures will gonna work? We'll see now. So data structures that are directly operated on the machine level instruction. So the data structure which is directly operated in the machine level instruction, that means what? It will be operate in the terms of zeros and ones. I no need to convert anything. So it is compiler generated things. That is what machine level instructions are known as primitive data structure. What do you mean by primitive data structure? It is a type of data structure where the data will going to be directly operated upon the machine level instruction. So here human intervention is not required. By default, machine will going to take all the data and information, then that will be used as a machine level instruction. That kind of data structure will be considered as what? Primitive data structure. Then what are the types of primitive data structures we have? So we have integers, float, character data, pointers are the primitive data structures. So if you consider the integer, then it will going to hold only whole numbers. It should not have any fractional part. So when it comes to the float, it will going to have both whole numbers as well as fractional part. For example, if I wanted to store a number called 2.38. So at that time, I should go with float instead of this integer. So if I wanted to have only 2, at that time, I have to go with a integer data type. Then we have a character data. It will stores characters, and also we have a pointer that will going to hold the address of another variable in a computer memory. This is what regarding primitive data structure. So now we'll see what are the operations that I can perform on the primitive data structure. So first operation is what? Create. So As the name indicates, create is used to create a new data structure. So as we all know that in the primitive data structure we have integer, character, float, pointers, reference, all those comes under this primitive data structure, isn't it? Then how I am going to create that? For that, I have to declare a variable. If I am declaring a variable, at that time with respect to a particular type of data type, the memory allocation will going to be takes place in a computer memory. That is how we are going to create a data structure. Anyhow, this integer, float, character, everything comes under this primitive data structure. When I am dealing with this create operation, create indicates we are creating a new data structure. So for example, if I am writing int x. What do you mean by this? X is a variable of a data type integer. So if I write int x, then it is of 2 or 4 bytes of memory will be allocated based on the type of processor that you have in your system, right? So either it will going to have 2 bytes or 4 bytes of memory for this integer. That means I'm creating a memory space in my computer's memory. When I'm creating this data structure, at the time with respect to that create operation, memory will going to be stored or memory will going to be created. So here create operation is used to create a new data structure, so that this operation reserves memory space for the program elements. It may be carried out at compile time and runtime. So the creation of this data structure can be takes place either at compile time or at runtime. When the program is running or at the time of execution also, I can create this data structure, or else before the execution, that is compile time. I hope you got to know regarding this. So in this, in the create, you can write the example like int x or float y. Okay, so this is how we are going to create. Next, what is the next operation? Select. Why I am going to use this select? As you know that we have many data, like it can be of same data or different data. So I wanted to fetch some data in order to perform some of the operation. Then I have to use a operation called select. So this operation is used by the programmers to access the data within the data structure. So this operation updates or alters the data. So as I told, if I wanted to update or if I wanted to alter some existing data, then I am going to use this select operation. So we got to know regarding create select. So once it is create, it needs to be destroyed. That means whatever the memory space that I have allocated, that needs to be removed on once its working is done. That is what regarding this destroy. So this operation is used to destroy or remove the data structure from the memory space. For example, by making use of create, I am going to create int x. So that means x is a variable of a data type called integer. At that time, 2 or 4 bytes of memory space will be allocated for my x variable. So once the working of this x variable is done, at that time that needs to be removed from the computer memory. For that reason, we are going to have this destroy operation. So this will going to destroy or remove the data structure from the memory space. So we'll see the next function, that is regarding this update. So functions, operations, methods, behavior, all are same. Here update in the sense this operation is used to change the data of a data structure. So that an assignment operation is a good example for this update. Let me take one example here. Consider int a is equal to 2. What is the value of a now? That is 2 of a data type called integer. So now what I am going to do, a is equal to 4. So previously what was the value of a? That is 2. As of now the value of a is 4. That means I have updated, I have assigned the value with the help of this assignment operator that is related to update. So we have 4 operations with respect to this primitive data structures, that includes create, select, and we have update as well as destroy. So I hope you all understood regarding this operations on primitive data structure, and this is also important in the perspective of your examination. So now we got to note the operations on primitive data structures. So now we'll see about the next one, that is non-primitive data structure. So as we all know that in the primitive data structure, that will going to be operated on a machine instruction, but when it comes to the non-primitive data structure, it will mainly related to what complex data structure. Why I am considering this as a complex data structure? Because this non-primitive data structures has been derived from the primitive data structure. That is why it will be considered as what? complex data structure. And also they mainly stress on the formation of groups of homogeneous as well as heterogeneous data structure. That means it can be a combination of what? Same kind of data elements or a different kinds of data elements. So when it is a homogeneous, same kind of data elements will be there. When it comes to the heterogeneous data elements, at the time different kinds of data elements will be there in the non-primitive data structures. And also we know that in the non-primitive data structure, so again this non-primitive data structures has been classified into arrays, list as well as files. So under the data structure of list, again we have a linear and non-linear. So now we'll see about the linear data structure as well as non-linear data structure. So now we'll see about this linear data structure. So as we all know that in the non-primitive data structure, again we have linear as well as non-linear, isn't it? So now we'll see about this linear data structure. As the name indicates, linear in the sense what? It will be in the sequential order. The memory allocation will be in the continuous manner here. So that linear data structures are kind of data structure that has homogeneous elements. Homogeneous in the sense what? Same kind of elements will be there in the linear data structure. So it will not going to have a different kind of element. For example, if I take the student details, so I can't take student details as a same kind of element. Why? Because student name comprises of character and student ID might be comprises of what? Numbers or numerics. And if I take the fees, that will be a float. So I can't consider student details as a homogeneous elements. That is not of the same type of elements. So that if I consider 10, 20, 30, so all these are the data elements which is of same data type. Like we have what? Whole numbers as well as we have one more whole number here. That means that contains no fraction part. So when we have a data structure that contain homogeneous elements or same kind of elements will be termed as what? Linear data structure here. So that the data structure in which elements are in a sequence form and of a linear series. So it will going to form a linear series. It will be in the sequence. So as I told, it will be in sequence, right? So 10, 20, 30, 40 I can take like that. So elements of homogeneous as well as the elements are in the sequence and also it form a linear series one after another. So that the linear data structures are very easy to implement since the memory of the computer is also organized in a linear fashion. Why it will be considered as easy in order to implement? So if you consider the computer memory, there also we have a linear data structure. That means 1001, 1003, 1005. That is what the memory allocation of computer memory. So that is also going to follow this linear data structure so that it will be easy in order to implement this linear data structure method. So that then what are the examples which comes under this linear? So it comprises of what? Stack, queue as well as linked list. So we are going to learn even all the three data structures in the coming session. So as of now you just understand linear in the sense what? Data elements will be arranged in sequence and it will be in the linear format and implementation will be easy because computer's memory follows linear data structure fashion and examples are stack, queue as well as linked list. So now we'll see about this non-linear data structure. So if it is a linear, sequence. If it is a non-linear, then there is no sequence. So then there will be a in this data structure in which data item is connected to several other data items. So here data item is not sequential or not in a sequence. So if it is sequence, then it will be like this. If it is not sequence, if the data item is connected to several data items, it could be like this, like 10 and it can be 20, 30. It could be like this. That is what non-linear data structure is all about. So data structure in the data item is connected to several data items in the non-linear data structures. So in this non-linear data structure, it may going to follow either hierarchical relationship or a parent-child relationship. Hierarchical in the sense tree-like structure. One root will be there, then it will going to have number of branches. So and also we have a parent-child relationship that can be represented with a non-linear data structure. So this non-linear data structures in that elements are not arranged in a sequential structure. That is why we are calling this as a non-linear data structure. Then what are the examples we can consider for this non-linear data structure? It comprises of graphs as well as trees. So trees and graphs are the example for this non-linear data structures. So now we got to know regarding this non-linear as well as linear. So now we'll see what are the operations that I can perform on the non-primitive data structures. So in the primitive, we can create, we can select, we can update and we can destroy. So when it comes to the operations on non-primitive data structure, we'll see what are the operations that I can perform. So first we have a traversing. As the name indicates, traversing in the sense what? I'm visiting each node or I'm visiting each data access element exactly once. So if you consider non-primitive, there also I have linear as well as non-linear. So you can consider this example here itself, 10, 20, 30 and one more will be 10, 20, 30. Okay, so consider this example. I have a two example with respect to linear and non-linear. Together I will comprise this that as a non-primitive. What is the first operation that I can perform on this? The traversing, that processing of accessing each element exactly once to perform some of the operation is called traversing. What is the traversing means? Here we are accessing or we are visiting each node or each data item exactly once in order to perform some of the operations. So here I am going to visit 10, then I will visit 20, then I will visit 30. That is what I am visiting or I am accessing each data items exactly once in order to perform some of the operation. Here also if I consider that I will come to 10, again I will reach to 20, then I will come back, again I will reach to 30. That means what? We are visiting each data item or we are accessing each data element exactly once. So that process is called as what? Traversing. So next we have insertion. Insertion in the sense what? As the name indicates, we are inserting some data item to the exiting data structure. So that the process of adding a new data element into the given collection of data elements is called insertion. So how many elements I have here? I have only 3. Now I wanted to add one more called 40. Can I do that? Yes. With a which operation? That is with the help of this insertion operator. I can add new data item or I can add new data elements to the existing set of data element. Then that process will be termed as what? Insertion. In the same way I can delete it, right? That is what deletion. The process of removing or deleting the existing data element from the given collection of data element is called deletion. So here I don't want 20. I will just remove this from the collection of data elements. Then it will be like 10, 30 as well as 40. Okay, this is what? Deletion. And also we have searching. What I am searching for here? The process of finding the location of a data element in the given collection of data element is called searching. I am checking for the location of data element. For example, if I consider 10, 30, 40. So here the address will going to start from 0th location, 0, 1, 2. So what is the location of an element called 30? That is 1. So it is in the location 1. What is the location or a memory address of this 40? That is 2. So what is the memory address or a location of this element called 10? That is 0. So searching in the sense what? I am finding the memory address or I am finding the memory location of a specific data items in the collection of data item. That process is called as what? Searching. So next we have sorting. So you just imagine I don't have what? Arranged values. So instead of that consider I have 20, 30, 10 and 40. So is this in the ascending order? No. So even is this in the descending order? No. I wanted to perform sorting operation. Then what do you mean by sorting here? The arrangements of data elements either in ascending order or descending order. So that is what sorting is all about. The process of arrangement of the data elements in ascending or descending order is called sorting. So here if I apply sorting, then what will be my resultant? 10, 20, 30 as well as we have 40. So this is how we are going to work with a sorting operation. At last we have merging. So as the name indicates, merge in the sense what? We are combining. What we are combining here? The process of combining the elements of two structures to form a single structure is called merging. So let me take one example here. Consider I have 20 and 30. Here I have one more structure called 10, 40. Okay. So when I'm performing this merging operation, at the time I'm going to combine these two. Then I'm going to form one more data structure called 10, 20, 30 as well as 40. That is what merging is all about. So the process of combining the elements of a data structure to form a single data structure is called merging. So what I can perform? So you just remember it as a TID SMS. So how to remember? TIDSMS. So what are the operations on non-primitive data structure? Traversing, insertion, deletion, searching, merging, sorting. This is how we are supposed to remember the operations on non-primitive data structures. I hope you all understood regarding what do you mean by data structure, what is the category of data structure, what is the use of having a data structure, then what is the types, that is category of a data structure. Under that we learned regarding primitive as well as the operations on primitive and non-primitive. Along with that we have a linear and non-linear. Then we have learned regarding this operations on non-primitive data structure. It's all about today's session. So in our next session we will be learning regarding this dynamic memory allocation. That will be the content of my next session. Until that, keep learning, keep on growing. Thank you.